Thank you very much to the whole Flyte community, David, as well, for inviting me to come and tell our very short experience so far with Flyte and the excitement that we have for the project. So my name is Jose Navarro. I joined Cleo just not even 2 months ago, so I'm very fresh to Flyte and Cleo. I joined as an MLOps engineer as part of the platform team, and I also ran MLOps community meetups in Bristol, UK. The platform team at Cleo, as like any platform team, is the goal is to provide services and tools to make engineers more efficient. In our case, we're working closely with the data science team, so that's why the MLOps. In particular, in this term, one of our goals is to enable data science teams to iterate faster on machine learning models. And what it means for us will be to iterate faster on ML models is that by iterating faster on them, we can launch new features quickly into production, and therefore trying to find what's valuable for our users in the product and what is bringing business value quicker, instead of having a long iteration to be able to deploy a new model or to retrain an existing model in production. Another valuable of like being able to iterate faster on models, we need to somehow have functionality around to have metadata about the training jobs that were done in the past and what data was needed to train that. So like having tools to be able to store that type of metadata, it's important for us in the context of this goal. And also it will mean to lower the barrier of ML at Cleo, so that if we make it easy to retrain existing models in production, that means that we don't need the specific expert that created that model to train that model to redeploy it. That means that other data science can retrain and deploy models that are existing in production, and potentially people who are outside the data science teams as well, like some like PMs potentially can have a look and see a model that haven't been retrained in a while, and maybe they want to figure a new retrain pipeline with more up-to-date data and see what's the evaluation like with within the tool, or maybe with other tools that have been piped into the training pipeline to evaluate the models. So to give you a little bit of context about Cleo's product, so Cleo is a fintech product. It's currently available in the US. It's pioneer in the conversational UI type of product. So we nowadays very used to conversational AI type of like products everywhere. But Cleo has been doing this type of product for like the last 6 years. And with the release and the advances of like the latest conversational AI type of models, we are being able to enrich our current product and enrich the experience for our users. Our mission is to empower people to build a life beyond paycheck. So especially helping young people who are like living paycheck to paycheck, and helping them in the journey to become feeling better about money. Some of the products that we have is salary advance, budget. Something that is very popular within the product is being able to be roasted by Cleo. So think about Cleo like a friend who you can basically talk about money and is conscious about your expenses and about your income, and then it can help you out, like, or pointing out that you are spending too much money on certain takeaways or Uber. So coming back to the goal for the platform team, we want to enable data science teams to iterate faster on ML models. So the current way of training at Cleo is mostly through local training. So like data scientists train models using the laptops. Fortunately, everything is version control, which is already good. But this is very good because it has allowed us to like go very fast. It's in the values of the organization to make it happen, learn at speed, go very, very fast. But since we have a number of successful ML models out there and that are bringing direct business value to the organization, and that coupled with an expansion of the data science team, so we're going to start bringing more and more data science teams. We need ways and standardize the way we train our models in a way that is more reliable, more reproducible, and iterating over them faster. So some of the things that I find about like local training is that usually, okay, so you have all your training scripts version controlled, but it's usually not a single script. You have maybe some scripts to like run some queries, pre-process some data, build the data sets. Then you have another script for the actual training of your model. Then you have a different script for evaluating. Maybe there are a few more things coming up, and a question usually that comes up if like someone else look into the training scripts from like other data scientists is like, okay, so you have like 5, 6 scripts here. There's no documentation, like in which order do I run these scripts? What type of parameters do I need? Another usual issue is the dependency management. Like data scientists have like local environments set up with like lots of dependencies, with no reflection on it on the training scripts, and that happens quite often. So like even if you get the order right for the scripts, there are maybe some like dependencies issues. Like, okay, so you have the dependencies, but you don't know exactly what the version is, and the script is failing somehow. You don't understand. You always have to come back to the owner of those training scripts, the original data science who create them. Another common issue that I noticed is that certain tasks require certain permissions, and some of those things are again not documented. So like to run a specific query on a table in a data warehouse, you need a specific permission that not everyone has, and that wasn't documented anywhere. And again, you have to rely on the original owner of those scripts. And then training results, artifacts, like where is the data set that was created stored somewhere? The evaluation results are stored somewhere. Where is the actual model for like trainings that were unsuccessful, if you want to run some like tests or something. So yeah, those are like common problems. So what we want to get is to somewhere like this, and these are like a couple of examples that I did with Flyte, like something where you can have everything end-to-end defined in a very Pythonic way, with everything, dependencies management, DAGs for like the correct order, dependencies management correctly set. You don't need to ask what type of resources you need to have for each step, because everything is defined. So some of the things that we're loving about Flyte is that it has a very easy Python API to build the DAGs. So that is really helpful for like data science teams that are very Pythonic centric. So they don't want to, or they shouldn't have to like learn all the Kubernetes underlying complexities and learn just another thing. They should be spending the time in what they are best, right? Which is just creating the best ML models out there. So having something that is very Pythonic, it helps a lot, because it's already you don't need to teach them, or they don't need to learn a lot of like new stuff to be able to build a Flyte workflow. Then custom images are really important. Like every single task that we run, they're gonna need some custom image. And we find very useful the image spec, and they loved when we showcase Flyte to them. One of the things that stand out, it was the image spec, because they didn't have to build like Docker images themselves anymore. They just have to define the dependencies, and then Flyte will like build that image and package it up with the tasks. Then as a platform engineer, it's very important for us to be able to provide compute resources per task, because sometimes like you want individual set of compute resources that are very expensive. Like you want to train on a GPU, but then the pre-processing of the data, all the queries that you need to do to prepare the data set, they can probably run on a more like cheaper instance, and being super easy for them to say, this needs GPU, this is just a regular CPU and memory type of task. It helps a lot to keep the cost under control. Then being able to pass permissions and get through service account. I haven't found, and again, maybe I see a few things that are not particular true, but I haven't found a way to provide the service account through the task without having to use the pod spec. And again, one of the benefits of using Flyte from my point of view, is for the data scientist not to have to understand what like the pod spec and the Kubernetes API is. So it will be great if we could like say like service account in this task will like use something else. Maybe that's possible. I haven't found it. Then being able to track like what artifact was produced by what workflow, and vice versa as well. So having that lineage of artifacts against the workflows. Then being able to have like version control in the workflow and environment separation by design, it's great. And then caching functionality, Dex is some like caching we already using. Dex we haven't used it yet, but it looks very extensible and it's very, very interesting for us. So that's what I have to say. Then I have a little demo showcase that I like to show you. This is just an example that I did, and it was quite exciting for me to work on it. And it was quite an important thing for us to showcase to the data scientists, because it's quite important for us to have hyperparameter tuning within Flyte, or in general for training models for a particular model that we have. But the rest of the models, they're not using hyperparameter tuning, and it's not because it's not useful for them. It's just because it's just an extra task that they need to do in order to try to like fine tune that model. If they train it locally, they have to like script everything. So it's just extra work for them to do, and we want to provide that and abstract some of the functionality that I'm going to show you now to the data scientists, and add them as like library tasks, so that they can just run hyperparameter tuning super easy through Flyte with Optuna, and pipe all the results into MLflow, which are another two open source projects. So it looks like this. So we have the Flyte workflow, and using the powerful dynamic workflows, parallelize some tuning params task that uses Optuna to run some hyperparameters space search, and then all the results are pushed into MLflow. So I'm gonna show you, I'm gonna click go for the workflow, and then while it's running, then I'll show you a little bit the code that produces this. So I have like two parameters. One is the number of trials, so how many training jobs we want to run per concurrency, and I'm gonna put like 5 concurrency jobs. So that will create an Optuna study, and then it will launch the dynamic workflow. And in the meantime, I will show you the code for it, which is incredibly simple. Can everyone see my VS Code? Yeah. So the workflow definition is super easy. So the parameters, as you saw, is number of trials and concurrency. I create the Optuna study that I can show you in a minute. That's a regular task. Then I call the parallel training jobs, which is the dynamic workflow with the result of the study, the experiment for pushing everything into MLflow, and then the parameters that were called. So create Optuna study is just gonna create the MLflow experiment and create the Optuna study, which Optuna is the library for hyperparameter search, just an open source tool. Then the parallel training jobs is the dynamic workflow, which will loop through the number of concurrency parameter, and then call the tune params task, and then append the result of it into best trials. The tune params is just a mock training job. So what is this doing? It defines the search space for the parameters and then just randomize the accuracy. So it's not doing any training, but we're gonna provide this as a library for our data scientists so that they can basically just implement the train code, and then everything else will be done automatically for them, and then returns the best trial for each one. And then I have like some simple get best trial that iterates over all the best trials, and then get the best of the best, and then one for like printing out the information. And about MLflow, so Optuna allows you to add a callback, and it's the one that we using to push the experiment, the MLflow experiment, so that every single trial can push the results of it. So yeah, so this work. Thank you to the demo gods. So as I said, it creates the Optuna study, and then it parallelizes the tune params. Each of these have run 5 mock of the training job, and then return the best trial, and then the result is passed. The list of these results is passed to the guest best trial, which is passed to the registered trial, and hopefully this one has like pushed the best trials. Well, I can access the logs, but we can actually see that the results should have been pushed into MLflow now. This is the MLflow view for my experiments that I run with Flyte in Optuna, and yeah, they can have a look into the results here, and then maybe they want to select an experiment different than what was the best of the best because of something, and then every single parameter used in that training, it was pushed, the metrics results and the tags and everything. But the important bit for us, it was that it was so simple to parallelize all these jobs using dynamic workflows with Flyte that it will allow us to abstract all this information into the tasks that we will provide in a library for them to just they will have to just to implement the training code basically. Right, come back. I don't have anything else, so if you have any questions, feel free to ask.
I have many questions, Jose. If I'm slightly unfair, I'll be kind, because my questions are going to be more like asking the Flyte developers really more questions than you questions. You're kind of like a proxy for those questions. CourseRich has a lot of code written in Go, and also everything else you can possibly name in Ruby and C# and everything you could possibly think of. How easy is it to integrate Flyte with microservices built into the languages? Do you just write Python code that does API calls to those services, or is there a more direct way of doing that?
There is hey, my name is Ketan. I'm one of the earlier creators of Flyte, no longer code as much. But there is an agent framework, and I'm sure there are people here who can demo it or show it. There is a documentation. The idea is Flyte backend itself is pluggable. So instead of creating containers or pods, when you want to invoke an API, that's a direct integration into the backend, and you can manage it at the backend without having to go through. Now you can of course write Python code to whatever you feel like. You want to call APIs, you can. Now there are problems with that. Like in some cases, we have some users who have done places where they invoke a endpoint, but that's a long running thing in that remote endpoint. And let's say that pod dies, or you terminate the task, and it's very hard to kill that long running job. And let's take an example. Let's say it's a SageMaker training job or something that's running for hours. That would be hard, right? But with agents, all of that life cycle is handled. It's a very, very simple Python API. I think somebody shared. And then the second one over there is it all runs locally as well, because agents are implemented in any language. They're gRPC based, but the default protocol that we have implemented is in Python. So if you're writing your APIs in Python, you can run everything locally and then hit a button and it goes to remote. So
Did you say it was JSON RPC?
gRPC.
JRPC, okay.
Yeah, it doesn't matter. Like that's the internal protocol. From a
Yeah,
user perspective, it looks as if you're just using Python objects.
Cool.
Underlying
Nice.
it with gRPC. Yeah.
That's great. Thank you.
Yeah, I think there is somebody or one of the core contributors has added a, I don't want to advertise this a lot, but an Airflow agent that takes Airflow operators and runs it inline and makes them very efficient. But you can basically see those examples and write your own, and they're pretty trivial to write.
I basically mentioned this meeting kind of offhand, just discovered it because I'm watching LinkedIn, and mentioned it to my manager who's operating from America, and he started getting a bit excited. So it could very well become Flyte users, but we'll see. We'll see.
Jose, I had a quick question. Thanks for the presentation. Have you looked into pruning? I've looked into hyperparameter tuning and for things where you want to preemptively kill a run, you need something stateful. Obviously, you can roll your own like RDBMS and connect to that in the Flyte tasks. Is that something you're looking into, or is it not like in your use case yet?
We have done it. It's fairly simple. It's completely you just create a database, and then when you create the study, you pass that database so that every single task that is running in parallel, it's pushing the results into the central database, and then Optuna is able to see that one of the trials is a bit unpromising and then prunes that automatically. Before that, we were running everything in parallel, and then we were running isolated trials, but then we added the database, and now it's like the whole parallel job is like orchestrated together, and like the best results of one trial in one task is helping other tasks to search in the right space and pruning some trials that are not very promising. So it's as simple as having a database.
And that database setup was simple enough. There isn't, you don't see a need like for a native thing in Flyte for that.
No. It's at least for Optuna, it has support for Postgres database, which is what we created a small Postgres database in AWS, which is the cloud where we are, and we just added some code to like get the URL with the secrets and everything. But yeah, super simple.
Okay, awesome, thanks.
I had a question on that. Great presentation, Jose. Thank you for sharing. My question, I also put it, I don't know, it's also for Niels and you maybe. Is it possible, because you already have MLflow integration in there, is it possible to just render that as a static, the exploration of your hyper search space, right? The nice pretty graph that you get in MLflow. You could render that as part of Flyte-based, and you may not even have to jump onto MLflow for the ones that have already completed. Yes, on real time, MLflow is useful, right? As you're watching and observing. I don't know how many people do that really. Nobody really does it, right? At the end of you look like it's, yeah, I know we all want real time, but who watches experiments in real time as it's happening? But Flyte-based is something you don't even need a database. You could just dump it into Flyte-based renderer, and it shows up directly in the UI. I don't know if you have explored it and if you found, whether you know about it, and maybe Niels also may want to chime in.
I definitely knew about it. I know that I had a look into the examples and how it is to create renderers there. I have done it. I have done an example where I was evaluating things within the task instead of like pushing things into MLflow, and then I was like creating the confusion metrics images, and then I was thinking like, oh, it will be cool if we have everything in a single place within Flyte. But the issue with that is that we always gonna need for now like MLflow for like MLflow is great for like tracking everything automatically if you're using like TensorFlow, PyTorch, some of the like regular type of like models. It tracks everything like very like, it does the auto logging thing that tracks a lot of the stuff, including like pushing the artifacts automatically to S3 as well.
Yep.
So and then we are intending to use model registry as well at some point. So having MLflow there is not going to go away, but I agree that like rendering some of the information within Flyte, it's pretty interesting to have everything in a single place. That
yeah
because the problem with the current MLflow plugin is it renders the training traces only for one task. Most people care about the experiment, so we'll need to somehow figure that out.
It was my first way to go with the MLflow plugin, but then I discovered that I couldn't pass the experiment run across to like have like different tasks doing things in the same experiment, and or even in the same experiment run sometimes.
Yeah, just to call out, the machine learning mental health handbook should have don't constantly refresh your experiment runs, because it's not good.
What do you mean? We want a real-time watch as the it slowly goes down.
I had more of a generic question for you there, Jose. Just speak, if you could speak a bit more about your experience with Kubernetes and your sort of maybe a bit your pain in the past, and exactly how this has helped you alleviate your pain. Because I know you've dealt with a lot of Jupyter Notebook stuff in the past, and random bits of Python, and I think bits of Ruby, and hacks upon hacks upon hacks. And how does your current experience now compare to what you used to deal with?
Again, my experience is still very short, but for this time, we chose not to tackle any of the dev experience into like trying to help with the like local experimentation, like the experimentation, so like Jupyter Notebooks and stuff. So what we're trying to help is like once you figure out your like experiment, maybe you have work in a Jupyter Notebook trying to figure out your training code and everything, then you build the training pipeline. But some things that I didn't expect is how easy it is to run the Flyte workflows locally as well. So I'm starting to think that maybe the need for Jupyter Hub to be able to do that experimentation, it goes away. by just running the pipelines locally over and over until you have something like that is currently like more or less like what you want, and then you just basically hit remote and then package your workflow and then register your workflow in the development, and then you start doing things remotely.
I mean,
So yeah.
On my end, I've got kind of a dual need for better machine learning tools, especially free open source ones, because I'm both doing core search and also the nonprofit dense analysis that I run, and both are now doing machine learning workflows. So I'm probably inevitably going to use Flyte for one, if not for core search, for also dense analysis. And the what you're describing there, with instead of using Jupyter notebooks, using some Flyte stuff locally would probably be exactly what I end up doing, because my friend slash fellow director George basically just use Vim, because you know us, we use Vim. So Vim is kind of our Jupyter notebook.
Yeah, just to add to what Jose said, that was our goal, to that you write code, you test it locally, you even unit test it. Like one day, we hope there will be parts of the code that people will unit test or generate fake data, send it through, right? Like do all of that locally, and when you're happy, hit a button and run it remote. That's the goal. That's the holy grail that we are going for with everything. Now it's almost close to realization, but there are problems, right? Like you may not have access to data, but this is where movement of data between the remote and local is also the thing that we're constantly working on, so that, let's say if you have a database query that results in a data frame, which is from Snowflake or whatever, you can materialize that remote, but access it local through a secure API only ephemerally, right? You're not going to store it and then throw it away. So that would be the holy grail. So.
I really appreciate that, because probably the most difficult thing to do, you set up your Kubernetes cluster and you run away with have all this automation of scaling things, and you build this entire ecosystem, all these services, and you can't run it locally. that is the problem you get with Kubernetes. I really appreciate any kind of tooling that makes it easier to run things locally. It's just a common issue with the instrumentation and orchestration.
Yeah. Hopefully Jose thinks that you can run most of the things locally. I think you're one of the latest users, so you should be able to tell.
Yeah, it's one of the things that I point out to the team, like, oh my God, I don't have to like hit remote every time to figure out that I wrote the name of the variable wrong. And I could like fix all those little issues locally before I just go and try to get a GPU out of AWS.
I'll also mention type checking in Python helps you with that issue quite a lot.
Yeah, that's one of the things that Flyte comes with, right? Having to have like strongly typed code.
Forces you almost. To some people's dismay, it forces you, but yeah, I think it's the right approach over the long term.
I'm a huge fan of Pyrite for type checking, which is a Microsoft's open source type checker. MyPy is also potentially good depending on what you're doing, but Pyrite's been my preferred option for a while now. It works quite well.
Jose, thanks for the presentation. It was really, really awesome. I'm curious how could you talk a bit about how you operationalized the platform for users? Like you had mentioned using image spec, you had mentioned like having data scientists like implement only the, training logic. Would just be curious to hear how does that process work? Like, do they create a PR and then you run an action that creates a Flyte workflow? Like, just curious how that works.
We still figuring out what our process is going to look like. We are in on the process of migrating our first training script that is producing a model that is in production to Flyte, and we're doing that just manually for now with them, helping them on the journey. We haven't instrumented or automated any of this process. We haven't figured out if we want to keep all our workflows in a monorepo, or if we want to like have everything like separated, or how like all of that we still we want to push this thing as far as possible and see where are the pain points, where are the things that we need to focus on, and then like all that, like hopefully by the time that we have this example, our idea of like how we want this to work, it's a lot clearer, and we don't fall into a process that it's not good for us. But in terms of like in terms of the abstractions, the way I'm thinking at the moment, we have this like library that we provide from the platform team called like Cleo Data, and from Cleo Data we can add like we have like an abstraction for data scientists to run like Kubernetes jobs, like super parallel, that they can like point to like the training or the inference code that they want, and then like a Kubernetes job is created like in parallel, like aggregates results, blah blah blah. So we were thinking about like things like the tasks that I show you, like create Optuna experiment, create MLflow experiment, maybe the dynamic workflow that generates or that is using the tune params stuff, like put it in the library and then just let the data scientists to do like from Cleo Data import hyperparameter task, and that comes with like all that, so they don't need to know, they just need to know that they need to create this like training code that they need to pass to the task, and that is basically launching everything. So trying to simplify as much as possible to them. So yeah, if they don't need to know what a dynamic workflow is, for us is better. I mean, they probably will figure out at some point if they continue using Flyte, but that's our like motto, like trying to abstract as much as possible.
Yeah, that's really interesting. Thanks for the insight, because we're always looking for like what's the kind of optimal, or what in reality happens when you give a platform team something like Flyte, like how many iterations does it go through before it touches the end user? And we've seen, you know, virtually untouched to people building, you know, image building service and otherwise untouched, to like going all the way to the other side and, you know, kind of fully abstracting the workflow orchestration part. So interesting to hear.
I think it depends on the organization. In my previous role, I got to the point where like the machine learning teams, they were like super experienced with Kubernetes. And that was because of the decisions that I made and the team made in the platform team to like add services and help them in the journey of like learning the Kubernetes side of things. And because our idea was that you build it, you operate it, like you have to like you own it completely. And that means that you need to go into the Kubernetes cluster and figure out if something is wrong. Whereas in Cleo is slightly different. It's more like everything is abstracted for the data scientist, which is great. I mean, everything seems to be working fine, and that means that the data scientists can focus in exactly what they need to. They don't know anything about Kubernetes. They don't have access to Kubernetes clusters. They just know that they have to like implement this code in this mono repo if they want a new service, and then they have to have like a YAML file with some values that will result in their service having more or less memory or more or less CPU or maybe a GPU, and everything behind the scenes is completely abstracted. We build the Docker images using like a template that we have, plus the code that they have, and install the dependencies that they give in, and build the hem release and apply that hem release. Everything is completely abstracted. So it depends on the organization and the culture of the company, I guess. And yeah, I've been in both ends. I'm torn at the moment. I like the Cleo way, but I'm pretty proud of what I got in the previous role with the ML team, knowing what a toleration was.
It's very interesting, because I tend to think of these things like different spheres of knowledge that you respect. Like a data scientist thinks in a very particular way and acts in a particular way, and engineers are think and act in different ways. And some people can do both. I don't think it should be required that people should be able to do both things. It's the same way that you can have clear separation between quality assurance and development, or separation between product management and yada yada. These are separate disciplines. Some people can learn both, but often you'll find people have like a specific discipline.
Yeah, definitely.
I mention that because at Course Reach, the challenge is quickly becoming one of many challenges. Just one of them is bridging the gap between an engineering team that has very little machine learning knowledge and data scientists and some experts in between who know a little bit here and there. It's sort of starting to bring into the company a bit more integration between data science and like active engineering work. So this is sort of why we're interested.
Sure. Yeah, thank you again, Jose. I had a question. I mean, so far in the past 2 months, you've been able to make a lot of progress, so that's great. But I was curious, what's been your #1 struggle with Flyte? I mean, what's been your probably main roadblock during the process? Maybe the answer will change with the time, but not sure.
I think we have hit a few rocks, but the community has been great. It's super responsive. Every time I have a question, I go to the Slack community and then I've got an answer in less than 5 hours because of the time difference. I will say that some of the things that I haven't figured out yet, it's as I have. So we use custom images with image spec. And when I try to use that with dynamic workflows, it tries to rebuild the image remotely because it evaluates like maybe, again, everything that I say, take it with a pinch of salt because it might be that I'm doing the wrong thing because I'm still very early in the process. But I was trying to like push this like dynamic workflow, which uses a custom image. And then when it tried to run in the remote, it was like complaining because he didn't have the Flyte-kit MD dependency because he was, in my opinion, he was trying to rebuild the image that, I mean, it already existed because it builds when you push it, but I don't know what was happening there. I basically changed that to the name of the image that I knew I built, and then I move on. But I need to revisit that. Maybe I'm doing something wrong with that. One of the things that we have spotted is that the scheduler, it's a single replica. And we would love to have a scheduler that we can make highly available with multiple replicas. Otherwise, I'm not sure if we're gonna be able to rely on Flyte to schedule training jobs. We can launch workflows locally, or we can hit the UI and retrain stuff through the UI, but I'm not sure. And again, maybe this is wrong. But having the scheduler as something that is highly available, and we have like multiple replicas, and we know that if something happens to one pod from the scheduler, it's going to be running somewhere else. It will be super important for us.
Is this the cron scheduler you're talking about?
Yeah.
Yeah, so that is, you shouldn't need, it will automatically, if one replica dies, the other one will come up, but one can handle hundreds of thousands. It's just, it's written
Yeah.
right? It's all go routine. That's like just it's just generating schedules and firing requests. It doesn't do it. It's a very trivial process. So it's not like, it's not reading DAG or workflows. It's not reading that. It's not doing. It just looks at a cron. It creates an in-memory timer pool, and boom. It's just, it can fire hundreds of thousands you have tried. So yeah, I don't think that's your problem. The problem will just be that the downstream may not be able to handle as fast as fire. So that's where you need capabilities in your system to have the, to scale.
So great to know, by the way. It's that would have been one of the issues we had to deal with, so it's good to know.
Yeah, the entire backend is written in Go. So even Flyte Propeller, that probably you're running single replica, but that's, you can scale it out, you can shard it out to multiple. But most of our users, even at like Spotify scale or something, running on 80,000, 50,000 workflows an hour or every minute, one Go process is enough because it's IO bound mostly. It's not really CPU bound. It's like 20-25% CPU utilization.
It's good to know. It's good to know. So yeah, I mean, that's all really. Being able to select like service account directly on the task will be interesting and nice for us, but that's like something that we can provide as well as a library, like as the service account, and then we build the pod spec for it. It's super simple, but having that like exposed within the task would be nice. But yeah, I mean, so far so good.
I think the dynamic image spec might just be a bug. I think we should just make sure that is the case. There might be some sort of regression. We don't know. If you can share an example, somebody in the community volunteered to try and find and fix it. So yeah, definitely share.
I will try to build a simple example and then see if I still see the same error, because this was like 2 weeks ago, so I might did something wrong, and then I just I was trying to go fast, and then I just copy the name of the image and the tag, and then I used that instead. So yeah, maybe I did something wrong. I don't know.
Maybe a bug, I feel, but yeah.
All right. If there are no more questions, thanks, Jose, for the presentation. Really appreciate you joining the Flyte community to share your experience. And yeah, that's all for today. The next community sync is on November 14th. If you'd like to speak, please add your name to the table present at the top of the agenda document, or you can just let us know. Thank you so much for your time and participation. See you all at the next community sync.
Thank you, everyone. Thank you for having me.
Thank you very much, Jose. That was
Gracias,
really good.
Jose.
That was great.
Thank you. Bye.
Okay.